have there was composite mapping based on the scheme given to us. And then when we have composite mapping, we say let G be a function which maps set A to set B, and f is another function that maps set B to C. The function or mapping that maps A to C is known as the composite mapping. That is, from A straight to C is the one we know as the composite mapping, and it is denoted by f of G this way, or you write it fg like this. Anyone you write is okay. So look at this illustration given to us here. Set A is having element x, y, z. Set B is having element p, q, and r. And set C is having element a, b, c. Now, set A, this is G here and this is F. If G takes an element in A, which is X, it will produce Q under B. And then if G takes Y under E, it will produce P under B. And then if G takes Z, at least it took Z as the input, it will produce R as the output under B. So now, if we now take B as the input now, F will take P and produce C, F will take Q and produce A, and then R will take what? F will take R and produce B. So now what you are saying is that G of F, which is the composite mapping, takes an element. Sorry, we are working with f of G now. F of G takes an element in A here and produces an image in C. So what we are saying is that if I have f of G of what? Let's take one of the elements here, which is x. So we all know that G of x will give me Q, so that means I'm having f of Q. And then what is f of Q? A. So that will give me A. The same thing with f of G of y. When G takes y here, it will produce P, right? So that will be f of P. And then when f takes P here, it will produce what? C. So I'm having C here. And the last one, f of G of Z is the third element here, which will produce what? F of, what is G of Z? When G takes Z, it will produce R. That will be f of R. And when f takes R, it will produce what? P. So now, in essence, what we are saying is that what? The composite mapping takes an element at A and then produce the image at C. And as you can see here, these are elements under A. And these are elements under C. I hope this is clear enough for us to understand what composite mapping is talking about. So now we are going to be looking at some examples so that we actually understand what we are doing, or how can we solve questions on this. So let's see some examples and see what we can do. Example. If f is a function which will map x to x plus 30, and g is another function which maps what? Let's say x squared minus 2. The question now said find f g. Let's say that is the first one, and the second check. When we have solution here, remember f of x was given to be what? X plus 3, and then g of x was given to be x squared minus 2. So what are we looking for now? F g of x. So what does that mean? When I have f g of x, that means that will be f. What's g of x? X squared minus 2. So what am I looking for now? F of x squared minus 2. What does this mean? This means that what? Anywhere I'm saying x now under f of x, I'll put the value of what? I'll put this value, which is x squared minus 2. I hope that's clear enough. Under f of x, instead of writing this x now, I will write this value x squared minus 2. So let's see what we are going to have. This will give me what? Instead of writing x plus 3 now, this x will be replaced with this, which means I'm having what? X squared minus 2. Then don't forget the plus 3 at the back, which will give me plus 3. So minus 2 plus 3 will give me what? 1, which means I'm left with what? X squared plus 1. And that's the value of f g of x. So now let's look for the value of g f of x now. So, which is the second part, g f of x. What does that mean? That is equals to g. What is f of x there? F of x was x plus 3. That will be g x plus 3. Then now I'm looking for g f x plus 3. What does that mean? Remember that g of x is what? X squared minus 2. Now that you are looking for g of x plus 3, that means that anywhere you are saying x under g of x, you are now putting x plus 3 here. So let's do that and see what we are going to have. G of x was x squared, so that means I will square this one now. X plus 3 squared. I hope you are following. Then I was having minus 2 there, I will still put it here. Let's expand this bracket now. That will give me x plus 3 multiplied by another x plus 3, then minus 2, right? So if that should be the case, let us open this bracket now. X times x will give me what? X squared. X times 3 will give me what? Plus 3x plus 3 times x will give me what? 3x plus 3 times plus 3 will give me what? Plus 9. Don't forget this minus 2 at the back now, right? So this will give me what? X squared plus 3x plus 3x will be 6x. 9 minus 2 is what? 7. So now, when you check this, you can clearly see that the value of g f of x is not the same thing with the value of f g of x. This means that what? In general, in most cases, composite mapping is not commutative. When we say commutative, it means that when I have A operation B and it is equals to B operation A, irrespective of what their arrangements, I'm having the same thing. In that case, they are commutative. But when you check this one we solve now, when we wrote f before g, our answer is different from when we are having g before f now. So which means they are not commutative. I hope this is clear enough. So under mapping and function, composite mapping in general is not commutative. Thank you. We are still going to add one more example so that we understand what we are doing. Number 2 example. Let's say we have given that f is given to be just the same way with what we did the other time. In this case, we are just using G and H, not F yet. So in that case, we don't have any problem to solve that. So what does this mean? I will still bring back my G first. Then what is H of X? H of X is 3x minus 4. So that means in brackets now I'm having 3x minus 4. So after having this, the next thing is to what? Put this value to replace my x under G of X. I hope that's taken. Now let's do that. That will give me x. G of X was x squared minus 1. So instead of writing x squared now, I'll write 3x minus 4 squared. So that means I'm having 3x minus 4 squared. Then the minus 1 is still coming. I hope this is clear. Now let's expand the brackets. 3x minus 4 multiplied by 3x minus 4. Minus 1 now. Let us open this. 3x times 3x will give us what? 9x squared. Right? 3x times minus 4 will give me minus 3 times 4 is 12. That will be 12x. Minus 4 times 3 will be the same thing. Minus 12x again, right? Minus 4 times minus 4 will give me plus 16. Then don't forget the minus 1 outside. That will give me minus 1. Right? So now, let us finish this. 9x squared minus 12x minus 12x should be minus 24x. 16 minus 1 should be plus 15. And that's the solution to what? GH of X as what implies. So we are done with A now. The answer is what? 9x squared minus 24x plus 15. Now, the second one I'm solving now is C. You should try and solve B and E, F yourself. I'm solving C now. They said that F of H of what? G. So what does this mean? It means that what? I will consider this first. So I'll be having F of H. What is G of X? G of X was given to be what? X squared minus 1. So I've done that one. Now, what does this mean? Anyway, I'm seeing this is now H of X squared minus 1 that we solve first. What does that mean? Anyway, I'm seeing X under H of X, I will put X squared minus 1. So this is H of X. So what does that mean? I'll be having F. F is still outside. We haven't touched that yet. Then in bracket, H of X squared, that will be 3. Instead of writing X, I will write what now? X squared minus 1. Then don't forget the minus 4 outside. Minus 4. Now, let us open this bracket first. F bracket. 3 times x squared will give me 3x squared. 3 times minus 1 will give me minus 3. Then minus 4. This will give me what? F 3x squared minus 3 minus 4 will give me minus 7. Now I'm looking for f of 3x squared minus 7. What does that mean? It means that anywhere I'm seeing x under f of x, I'll put all this value down. Now let's do that and see what we're going to have. So this means f of x is what? X plus 2. Instead of x, I'll write this value now. That will be 3x squared minus 7. That is x, right? Then the plus 2 will still come. Now let us finish this. That will be 3x squared. Minus 7 plus 2 will give us what? Minus 5. And that will be the what? Solution to this. 3x squared minus 5. Now we are going to try solving f of h of g now. That is, this is the next thing we are going to do, right? So let's see what we are going to have now. F of h of g. This is what we want to do now, right? So this means that what? I'll be having f h of what? What is g of x? G of x was x squared minus So now I can still leave this one now and just do, okay, let's do it this way now. F h of d, yeah, this is what I was meant to do. That one I saw was actually for f of h of d. Now we are looking for what? This one now. So this means that what? Anywhere I'm seeing x under f of x, I'll be putting hg now. What was f of x? We have x plus 2. That instead of writing x plus 2 now, write hg plus 2. Now I'm looking for h of g. So which means that what I will consider g of x first. So what is g of x? G of x was given to be what? X squared minus 1, right? So after we have that, x squared minus 1 from g of x plus the 2 here. Now let's open this one and see what we are going to have. This means that what? Anywhere I'm seeing x under h of x, I will be writing x squared minus 1. So what is h of x? h of x was 3x minus 4. That means I'm having 3 bracket x squared minus 1. I hope that's okay. Then minus 4 outside. This plus 2 as well. Plus 2. I hope that's okay. Now let us open this bracket. 3 times this will give us 3x squared minus 3, right? Minus 4 plus 2 will give me what? Minus 2. Yes or no? So now let's solve this. What are you going to have? 3x squared. Minus 3 minus 2 is what? Minus 5. And that's the answer. And when you check now, you see that we are having the same thing. When we firstly consider f of h before g, or we consider h of g before f. So in that case, when we are having this kind of operation like this is known as the associative operation or associative property rather, or law. So that is when I'm having A operation B operation C, and my answer is the same thing as A operation B operation C. Then we say it satisfies the property of what? Associative. And in this case, we can see that what? Composite mapping satisfy the property of associative law. So which means that what? Composite mapping is associative in general, but